Well, hello, good morning. Thanks very much, Simon Pierre. And I just want to say hello to a couple of very good friends that I have been helping in this collaboration for many years, and Deep and everyone. Thanks very much for your invitation. I can say hello from here. And well, this is a presentation. Let me share the screen very quickly about the research that we've been doing at the Mexican Center for Music and Sonic Arts, CEMAS, as Simon Pierre was saying, and especially the tool that Francisco has developed as part of his PhD research. So CEMAS, some of you may know, is the Mexican Center for Music and Sonic Arts that is based in Morelia, Mexico. And for the past 6, almost 7 years, we have been part of, on the academic side of the National University of Mexico, which is the UNAM, at the campus in Morelia, where we run the Music and Technology undergrad program. And we have about 70 students doing their work there, and we have been working with them for a very long time. And then we also have a collaboration. We can also work at the postgrad level with the National School of Music that also belongs to UNAM, where Francisco did the PhD. And that's the place where we've been doing a lot of research in the master's and PhD levels with different composers and artists. And we chose Francisco PhD because, of course, Francisco is also the subdirector of CEMAS, and we've been working together for years. He's been in Montreal for these activities and everything. Some of you already know Francisco. He's an accomplished composer himself, and he teaches many different subjects at the university, and he's also a full-time staff at the UNAM. So that's why we chose this. So very briefly, just for those who don't know CEMAS not only runs the undergrad and the academic activities or the education activities, but we also run quite a lot of concert series. We publish books, and we have a residency space that we've been working for a very long time with many people in Canada that I'm just checking if we have some Canadians here. Well, Geraldine Aguiluz is from Montreal, and we have this activity with Concordia University that we work quite a lot, and of course UCAM, Xavier and Simon Pierre have been to Mexico for our festival, which is Visiones Sonoras, that we run from Mexico, and we also are doing this festival in September. This year, this is the 18th edition, and we all run this through the university, the UNAM, and this partnership between CEMAS and UNAM, the National University of Mexico, with the Morelia campus. We also have these spaces and studios for residencies where people can apply and spend some time, and there are a couple of special grants between Mexico and Canada. We also run the GTTP prize this year for Latin American and Canadian composers from the CEC. So as you can see, we have a lot of connections with Montreal, of course, with Quebec in general, and with Canada in general, with some funding available and everything. So I mentioned that because as we've done in the previous years, we are always happy to receive artists, researchers, and performers from Montreal and from Quebec or Canada in general. We also run this journal, which is the Sonic Ideas, a journal published by CEMAS that has been running for 14 years, which is both in English and Spanish, most of it. It's all online, and we also print the journal in case you are interested. Some of the issues are already there at Hexagram or UCAM. And we are always also accepting articles and texts in case you want to publish for Latin American audiences especially. And since the pandemic, for the previous few years, as Francisco was developing this tool and everything during his final 2 years of the PhD, we also adapted some of our educational programs into what we call CEMAS Plus. It's not very original to add a plus to the end of a word nowadays, but this is an online system or an online platform where people can access our courses and everything. So now that the pandemic is slowly fading away in Mexico, and we just got back to in-person activities last month in March. So it's very new, but we also are planning to keep our online platform to be able to share projects and courses and some education at different levels in Latin America. So that was something also I wanted to show you. But what's the most important thing today is to share with you one of our main, or maybe the main research project we've done in the past 4.5 years, which is something that Francisco has been developing for many years. He's going to explain you a little bit more about that, which is this AMI algorithmic composition tool that was part of his PhD, but it also goes beyond that because Francisco is an expert in Max and many other things, Max MSP and many other things, as some of you already know. And he decided to put together this amazing research program, creating a tool for composition that he's going to explain about. And as part of today's activities, we wanted to go deep into one of the projects developed at CEMAS and UNAM, and that's why we chose Francisco. So I hope you like it. At the end, of course, we can have questions, mainly hopefully for Francisco in terms of the tool. And eventually, Francisco is going to share this tool with so other composers can work for it. We can get some feedback. Francisco is going to publish a couple of articles about it, and we're planning to start promoting the tool as much as possible. So you are always welcome to explore and use it in the future if you are interested. So thanks very much, and I'll stop sharing so Francisco can share his screen. Francisco, go ahead. Thanks very much.
Okay, thank you very much, Rodrigo. And thanks everybody there, GRMS, to invite us to participate in this activity. So yes, I will share my screen. Okay. Okay. And I will present you. It's okay? Can you see that? Okay. I will present you this, or I will do this presentation, but after that I will show you a little bit the actual tool. But this tool is called AMI because it's algorithmic music interface, no? And the idea of this software, the idea of this software was to create. I need to move the screen here. Yeah, okay. To create a tool capable of generating symbolic musical data and classifying it. So that's probably the second part is the most important part to me, because the idea is to implement this in a friendly environment, and where it's not necessary for the user to be an expert in mathematics and programming. So sorry for that. And so the structure of this software is that I had a generation, let's say, part where I can generate data, so notes and velocities and rhythms, etc. But to generate this, I will use different kind of algorithms. But I want to classify that, and to do that, I need to analyze all the things I'm doing, or all the things I generated. So, but the thing here is the question, at least to me, is why do you want to do something like that? No, why are you going to work with algorithmic process? So, and one thing that for me is important is, can the audience hear, or even the composer hear the different algorithms? And to me, I think that that is not important if you can hear it or not. And I was inspired by these writings here. Laurie Spiegel in this article called Thoughts on Composing with Algorithms. She says that you can use the algorithmic processes as an illusion, no? So to simulate natural events more like a perception of the process than exactly replica, no? Yeah, you can simulate something that is very difficult to simulate using, pen and paper, but with the algorithmic processes, it's much easy to yeah, to have some result in that sense, no? Well, this is another way to use it, like, as a reverse analysis to apply rules on a computer based on famous music from the past. This is not my approach. This is our kind of, I mean, this is the approach where the composer wants to analyze, let's say, Bach music, and this person wants to create an algorithm to compose in that style, but it's not my approach. A scientific model to implement using a set of color rules, data generators designed to be cognitively meaningful or understandable. And probably this is my main approach, no? To implement, sorry. And probably this is my main approach because I want to generate data that is cognitively meaningful, but that you can use it in a very creative way, no? The other one is process imitation, coding in a computer the rules by which some natural phenomena occurs, develops or progress, and mimic of the process result, literally map specific non-musical data into musical variables. That is more like a sonification approach. It's not my approach, but it's another approach, and a mixture of all of this, no? So, and of course, there is a lot of software. I don't know if a lot, but there is plenty of software to work with the algorithmic composition. For example, Open Music is one of them, and Opus Modus, for example, is another one. In my case, I don't want to create, in fact, I cannot create, an entire environment, no, like Open Music. My thing is a little bit more humble, but the idea is to create something implemented in Max for Live, because my perception is that all these other softwares like Open Music and Opus Modus are not that easy to use for the normal composer. I mean, the composer that doesn't work a lot with programming and with mathematics and all the stuff. And in the case of Open Music, at least to me, the documentation is very, very poor. So it's very difficult to learn and to know all the objects using the documentation. And Opus Modus is very well documented, but this, you need to learn this kind of language to use it, no? So, but of course, that Max for Live, it has some things that are not the best thing. That is a commercial software. Of course, this could be made better if you can implement it in a free software, but I'm using Max since 1998, so my main tool is Max, so I know how to do it in that. But on the other hand, Max for Live is very popular. There is a big community around the world using Max and Live, mostly Live, of course, but Max and Live. The documentation is very good. It's in constant development. It's very stable to use it live, and other things multi-platform, so you can use it in Macintosh and PC, no? So for me, all those characteristics of these two softwares are very important to me, at least to implement my tool. So Amy this is the interface, at least now, and in Amy you have this. I will show the actual software, but let me show you this part. You have this editor here, and you can open this window, and in here you can generate pitch, rhythms, and dynamics, no? So for example, in the case of pitches, you can generate, you can choose the notes you're going to use, and you can use the different ways to choose those notes. For example, one is directly from this keyboard. The other one is if you want to use pitch class, Allen Forte pitch class, you can use it here. Or if you want to use this chromatic circle, etc. And here, for example, if you use, I mean, any way you use to choose the notes, there you have all the subgroups, no, that you can form with these nodes, no. This is more in the Allen Forte school, and of course you can transpose, invert, and you can choose the octaves you want to use, etc. But that nodes are the nodes that you are going to use to map these profiles that you can generate here with different algorithms, no? And when you choose an algorithm, you can choose we can modify the parameters, and after that you have this. You can see there is like a profile, and you are going to map that profile with the nodes you choose. So, and of course you are going to have a score, no? The same thing is for the rhythms with other implementations, of course, and for the dynamics. So to generate data, I'm using, until now, in this moment, the tool uses these algorithms. It's L systems that are used for that imitates the growth of a plant or of a tree. Chaotic system, different kinds of chaotic systems. For example, logistic, quadratic, the congruential, different kind of chaos. Random process, like random, for example, drunk, the system, or this kind of this one step random, this kind of random process. Cellular automata, and the last one is I cannot see it here because I have the screen. Let me move this. Yeah, genetics. I have genetics algorithms and cellular automata. No, so but the idea here to me is how to classify this, because the problem for me is that okay, you can generate a lot of data, but how can you relate that data, no, in some way? Because I discovered this many years ago when I started to work with algorithmic process, that okay, you can generate a lot of things, but okay, but at the end, how can I relate all those things, no? And to do that, you need, of course, first analyze what you are generating, and to do that analysis in this software, I'm using again different approaches. No, one is this ICV sim, a standard deviation, entropy, blah blah blah, editing distance, etc. So there is a lot of different approach to analyze this information. But the idea is that some of these analyses are not, let's say, very musical, in the sense that, for example, the entropy is the amount of chaos. Let me, where is the, sorry, here is the example, no? The amount of chaos of one system. So if you say that two different melodies are similar because they have the same amount of chaos, okay, that is one way to relate them, but you are not saying that those melodies are equal, no? You are relating that taking into account the chaos. So for example, in this case, I have that, and this, And probably it seems that the first one and the third one are the more similar, but if you take into account the entropy, it's not like that. I mean, the first one and the second one are more similar, no? Because the last one, it has more changes and more chaos, let's say. So, so I'm using all these different kinds of analysis to create a map, no, a map in two dimensions, no, in this Cartesian system where you have two different kind of analysis, and you can put the clips or the data you are creating in different part of the space, no, using this Cartesian system. So, sorry, let me pass this part. Okay, so to relate or to find, let's say, a hierarchy between these clips, I'm using this nearest neighbor algorithm. It's an algorithm used in ¿cómo se llama? Machine learning, no, to find the things that are, you know, closer to the clip that you are choosing, no. So in that sense, you can say that this specific sequence is closer than this one, and this is a little bit far, and this is a little far, and so on, no. So let me show you the software itself. Here, I have this live session, and here I have three tracks. In the first one, I have the tool, and I have two more tracks only with an instrument, let's say with piano or something like that, no? So for example, here I have the tool, and when I push editor, I can open this, and I can say, okay, I will use to create the profile of pitches, I will use, let's say, a chaotic system of one dimension, and in that sense, I will use congruential chaos. So after that, I can modify the parameters of this chaotic system, and I can choose the nodes I'm going to use. For example, I can use here a scale, for example, this scale. Okay. And here you can say, okay, I want to use from this octave to this octave. Okay, now I can listen to this. Okay, and if it's okay for you, you can generate here a rhythm. Let's say I will use random walk, and okay, with some amount of silence. This is the percentage of silence you are going to use. I mean, this is like a random silence, no? But how much silence do you want to introduce? Okay, and here I'm using some kind of graphic dynamics. That is, I will use groups of 2, 3, 4, 3, 2 different nodes, and I have different dynamics for these groups. Okay, so I can generate this, and I can listen to this. Okay, let me change the tempo. So, okay. Okay, let's say that I like that, so I can store this in any track I want. I will store it here in the first one. Okay, I will generate something else very quickly. Let's say I will use another kind of, okay, blah, blah, blah. Okay, I generate that. Okay, this goes to the second track. Third track. I mean, I'm doing something very fast now, so I'm not checking what is generating, but it's only for this example. Okay. Okay, last one, 4. Okay, you can imagine that here, let's say I have, I don't know, 6 or 7 different tracks with a lot of clips, let's say with 20 clips in every track. So how can I relate those clips in the sense, how can I relate in the sense that can I have some hierarchy here? So here I'm using this analyzer, and I say, okay, I want to analyze the first track. And inside the first track, I want to analyze, for example, the entropy of the pitch and let's say, yeah, the chronotonic distance. No, and I want to analyze 4 of them. Okay, I select the clip, and now the system tells me that if I select this one is the one that is more related with this one. After that, this, and after that, this. You know, but I can use this through all the tracks if I want. So I can relate all the clips in my session. If I select another clip, let's say I select this now, so now the order will be different. No, so with this idea, let me show you a little, very fast, a little example, or 2 examples I created here with this tool. For example, this one is more like let's say popular thing, more like using bass and drums and percussion. No, for example. Okay, and here there's another example using like an Pierrot ensemble, more contemporary style music. Okay, in this example, for me it's interesting because I'm in, for example, in this Pierrot ensemble, I of course I'm using a lot of articulation and things like that. That it's not, they are not created with the tool, but this is my idea. The idea is that the tool helps you to create data, pitch and rhythms and dynamics, but after that you can use that data to change it in any way you want, and to use any articulations and things to work with the timbre. No, in fact, I love to use this tool with my modular synthesizer. So I use this to control my synthesizers, and then there I start to modify the sound. Of course, there is a lot of things that I need to improve here and to add here: polyphony, other types of analysis, generation from constraints, improving the rhythmic pattern. I mean, this first stage is, is the first stage. I need to start to grow, this tool. Well, that's all. If you want to, I think that yes, we are in a good time. If you have any questions, please do it. Let me stop to sharing the screen. Okay.
Thank you very much, Francisco, for your. I know you're a very hard worker guy, and I can see the result here. And thank you also, Rodrigo. Donc, est-ce qu'on aurait des questions? Il nous reste quelques minutes quand même pour Sandy, oui, non? Ah, ok, parce que tu me regardais. Donc, maybe I will try one question. We already talked a little bit together before. I'm a more, I would say, electroacoustic composer, and my roots are French acousmatic or French electroacoustic. So I was wondering how a so nice tool could help us. I know it would mean a lot of DSP job beside in the back, but how could we have a tool of this quality applied to sound itself, to classify and so on? Because we have to do all this job, but we're doing it by ourselves. I remember I had before I was using Excel or other software to classify all my sound, but at the end now I just I just go free, you know. But you get a lot of sound. It's not classified. It's not organized on one side, analysis side. On the other side, to generate and organize like you're doing. So that's my open question.
Yeah, yeah. In fact, this is a very good question because of course the two main things that this tool doesn't have is something to work with timbre and something to work with the specialization, for example. And of course, is you are not working with the sound itself. To generate sounds, I mean, this thing that you are saying, Simon Pierre, is for me is very very interesting. And but to me is something that probably could be my next big research, no? Because it's very very difficult to create a tool to to generate sound algorithmically, but because there is a lot of parameters you can use, but but it's very possible to create a tool inside Max for Live to classify sounds. So let's say that you have a lot of different samples in different tracks, and you can relate those using some classification. No, so it's not that difficult to create a system to classify sounds inside this platform. So yeah, that's is something that my tool doesn't do, but I of course I want to continue because as I told you, this is the first step. No, I want to grow this and to add a lot of new stuff. So, but to me, because this is a work for my PhD, I needed to have some boundaries. I need to finish. So yes, but yeah, I will continue using it and yeah, in growing it and of course, as Rodrigo told you, I will share this tool so you can check it and help me to debug it. That's the idea.
And very quickly, just to add something, Simon Pierre, it's true what Francisco is saying about the boundaries, but in terms of the research, I mean, as an acousmatic composer myself and everything, it's always easier, that's my opinion, to relate to a tool like this to help us organize without the tool being able to analyze the sound itself, but to organize materials and everything. That's not that difficult. That's what I've been thinking about throughout the process of Francisco working. And of course, there are also other research in terms of analyzing the soundscapes and everything that has been done at the NES and everything that can always be related. Because I think in my perspective, it's always easier for an acousmatic composer to connect this idea of having the sounds and then a tool to organize the structure of a piece and the compositional aid, and then just assigning the sounds. And I don't really think that it's that difficult when you have support to organize and to structure the piece, which is the origin of what Francisco was doing, to understand not only microstructure but a macrostructure of a piece. And that's why I think it's a very good start, and it has many ramifications that can be added, and of course the whole debugging process that Francisco needs to do, and maybe a new version that includes DSP or sound analysis or whatever.
Yeah, Correct.
My goal was to say, oh, it was so good that I would like it to have this part, you know. And
Okay,
anyway,
I will do it for you, Simon Pierre.
yeah,
Don't worry.
You'll have it for next Saturday.
Yeah, exactly.
not
Give
too
us
expensive.
one
Okay,
week.
a special version for me, not too expensive. Okay,
Yeah.
but let's finish because I think that we will have a special conference maybe in fall with our students, with Ricardo's students and Sandeep at Concordia and some of McGill. Then we could have more time to go deeper in the software and the real nice tool that you did. So thank you very much. You can follow up.
Hola, Ricardo.
Here is Ricardo.
Yes, thanks very much. And we also have some of
Yeah.
Ricardo students in Morelia in August. So
Okay. Yeah. Thank
Gracias.
you very much.
thank you.
Gracias.
Ciao, everybody.
Chao.